Well, hello everyone, and welcome to this ELLEGO webinar. My name is Minna Kreivi, and I'm hosting this webinar together with ELLEGO. Let's see, I cannot see exactly how many we are at the moment, but we want to start in time, so let's start. So this is the second part of our two-part webinar series, and we are having a closer look here at ELLEGO's new LED technology, LED lighting solution, AGL 3.0. The first webinar was held 2 weeks ago. Thanks for everybody who attended. And the first part was focusing on the technology framework and engineering behind this AGL 3.0. This second part is more about sustainability, total cost of operations, and the benefits of low AGL currents. Just a few things before we start. So firstly, this webinar and all the future webinars will be streamed in LinkedIn Live and also YouTube Live. So if you haven't done it already, please click to ELLEGO LinkedIn and also YouTube and follow us. That way you will receive all the updates regarding to the future webinars and all product updates may have, and also some socials even that we are planning. Second thing, as the last time, we have reserved some time for questions and answers after the presentation. So if you have any questions or comments during the presentation, write them to the comment section and we will go them through after the presentation. Lastly, we are happy to receive any feedback to improve this and our future content. So anything regarding to the concept or content or channel or any other topic, just please let us know. We are happy to receive any feedback. This webinar will be recorded, and you will find the recordings from ELLEGO websites and also from LinkedIn and YouTube. From ELLEGO website, they are in www.ellego.fi/webinars. This is basically the first time when we are in YouTube Live, but we have something interesting coming on in the making. So I would definitely recommend you to following us in social media. So we want to keep this webinar short and straight to the topic, and meaning that I will stop speaking very soon. We have reserved 30 minutes time for the presentation, and after that about 15-20 minutes for potential questions and comments. I think I'm done, and I'm going to turn it over to our speaker, Terho Kaikuranta, who is ELLEGO's head of R&D. And Terho has been working on this AGL 3.0 development team since the day one when the project got started over 5 years ago. Let me pull Terho in. Hi, Terho.
Hello, everyone.
Welcome to the studio. How are you?
I'm fine, thank you.
All right, so I will share the presentation, or if you want to try to share it, you can share it, and maybe you have better control over the material.
Okay, let's see.
Or I can, well, I added it to the stream. So
Okay.
Let me know if you cannot change the slides and I will do it.
Okay, let's try.
Okay, let's start.
So welcome on my behalf as well. So let's go ahead and take a look what's coming. But first, a few words about the ELLEGO as a company. So we are actually not that known in airport business at the moment, but we have a Finnish power electronics company coming from the southwest coast of Finland. We have been founded in 1979, so this is not a fresh startup. We have pretty much experience in power electronics and also including the manufacturing of CCRs for over 30 years. So this is something we know pretty well. To start with, let's first take a look on the webinar 1 key points on the technology side so that everybody has this fundamental information on what we are talking about in technical terms. So we have named this AGL 3.0 solution, meaning that this is the LED-based Airfield lighting solution which uses very low currents, which go down to the native LED component current levels. So there are not much extra current used, what is minimally needed. And this will actually lead to the situation where in a typical AGL installation, up to 95% of energy savings can be achieved. You will soon see how this has been realized in real life. But that's quite a nice target to have in these years. And what kind of circuits AGL3 is? So basically this is a typical constant current series circuit. The main point here is that the power is controlled centrally only in CCR. That also means that there is no power control function inside each fixture at all. Basically, what has been changed compared to the old original halogen system is that this 6.6 amp currents will be replaced by this AGL 3.0 current. And this means that the maximum current is around 2.4 amps and low end goes practically to 0. So quite a lower currents. And other main principle is that let's keep everything which airports have already installed and what is working, basically meaning light fixtures, lamp transformers, and cabling. And then replace only what is necessary in order to make AGL 3.0 working. And in practical, that basically means the light bulbs, the LED lamps, replacing the halogen bulbs, and new type of CCRs. But this is the minimal change what is needed to implement AGL 3.0. And to give some sort of idea about the new products, we have these LED lamps practically available for all main applications airports might have, including the inset lamps, elevated lamps, and also the guidance signs and the CCR. And in this inset lamp picture, you can see what it looks in practice. So there is LED lamps inside the lamp fixture and no control electric ports is there at all. Okay, and then we go to the sustainability point of view. So this is how ICAO has identified the main circular economy principles, how it relates to the airports. So whole idea is the sustainable pathway to the future. So idea is to remove or delete, reduce the consumption and try to circulate as much as possible, which is of course a nice target. The first principle is that components, products and systems should be designed so that they produce minimal waste and pollution. So that's kind of the reduction, system reduction principle. Second principle is that products and systems should keep products and materials in use what they already have installed. So minimizing the need to buy something new. So that's the reuse principle. And the third one is the regenerate natural systems, so recycling as much as possible. And these three principles are the main points that ICAO sees, which are the guidelines for the airports in implementing the path to the sustainable future. And what this then means in the AGL systems, especially in the AGL 3.0, reduction will focus on the energy consumption, material consumption, effort, meaning mainly maintenance work and also investment efforts, and then operative cost. The reuse part, second principle, will focus on keeping what is working and replacing only what is necessary. And third principle, the recycling, of course, means materials and energy sources, which can be sustainable for the future. And let's now take a look on each of these three principles, what they mean in practice. So first about the reduction. So the AGL 3.0 actually produces required light intensities with minimal amount of energy consumption and minimal energy losses. It needs minimal amount of material in the equipment, spare parts, and eventually in waste. Also, the minimal system complexity is used, meaning that there is no need to build very, very difficult complex systems. And also the total cost of ownership can be minimized. So it means the money spending and also the extended lifetime. And all this then means that the airports can increase efficiency and sustainability of the airports. A closer look to the energy consumption. So we mentioned that over 90% drop in electricity consumption is possible and reachable. This graph illustrates the relative difference in the energy consumption. The left one, the 6.6 amp halogen circuits, are the original reference point. And in the middle, we have the 6.6 amp LED circuits. And on the right, the AGL 3.0. And this kind of shows the overall relationship between the energy consumption. And we can, of course, see that the AGL3 energy consumption is very low. This have also some secondary implications. For example, if you are using diesel generators as a backup power, using oil for those, you can reduce the oil dependency and maybe consider using solar UPS system backup power. Another secondary implication is that the CO2 compensation fees, the money airports are already spending, can be actually used for reducing the actual emissions, which makes more sense. But this energy efficiency, of course, increases, and as it increases the OPEX savings. And of course, this evaluation has been done a bit earlier, so the current energy price or electricity price trend seem to be getting into more expensive direction, so that need to be taken into account as well. And then maybe some sort of explanation where this saving comes from. So we have divided this energy consumption to the energy consumed inside the fixture and also consumed in the energy losses in the cabling. And as you can see in the graph, the cabling energy losses are actually eliminated in this AGL 3.0. So that's the main source of the energy saving principle here. And this is like its LED illumination has been consuming the natural LED efficiency as such, which is good, of course, but then AGL3 goes further by eliminating the cable losses as well. That was kind of the maybe a theoretical concept, but what happens in the real life is shown here. This example or measurement results is from the Turku airport in Finland, where we have a system installed, and we have been measuring that, what's the real energy consumption achievements are there. So the case is that we had the installed new CCR, and we also took 130 halogen bulbs and installed the new LED lamps in the same fixtures. and including also some signs. And then when we measure the power consumption, what we notice is that when having the 100% full light intensity, power consumption originally was over 9 kilowatts, and after this installation, it dropped down to the 760 watts. And that equals 91% of reduction in energy consumption. And then in the low intensity end, 10%, we had other measurement. And there the difference goes from 2.7 kilowatts down to 110 watts. So the achieved saving was 96%. And these are the actual measured savings from the real circuit, real airport. And maybe a good thing to note is also that this was measured from the CCR AC input side, meaning that all possible losses in the whole circuit and CCR are included in these numbers. So this is already achieved and verified. Then we go to the material consumption side of the reduction. So for AGL 3.0 type of circuits, there is only one CCR type that is used with all the applications, meaning that we don't have different power rating types of CCRs. Like today you might have a 30 kilowatt CCR, but we use only this one type. So it means that the CCR itself is the kind of the lowest, lightest model and consuming minimal amount of material. Then there is this fact that you don't need power control electronics inside each fixture. So that reduces quite a lot of material from the system. There is also need for less new fixture components because you can reuse some of the existing components you already have in the Airfield. And then in case you want to have a new installation or new equipment, you can choose and use smaller lamp transformers and thinner circuit cables. So these both reduce the material consumption as well. And it also happens that this cable wearing is not so intense with using AGL 3.0. So it means that the lifetime of cabling will be longer. So it's also some sort of the reduction that you can reduce the cable consumption. And of course, this kind of material consumption reduction mostly are related to manufacturing phase of the products and components. But overall, this will increase the CapEx efficiency and offers also very long lifetimes. And then in order to understand what this material reduction possibility means in practice, we have kind of calculated this kind of example compared to the Frankfurt and Man-sized airports, that what the impact will be in that scale. And now comparing to what they have installed at the moment means that if they would replace all AGL equipment with this AGL 3, that could offer possibility to save material 50 tons out from the CCR weights, the total CCR weight. 20 tons of power electronics is avoided totally in fixtures. And in case the smaller transformers are used, 90 tons of material can be get out from that. And same goes to the cabling, 170 tons out of the copper. This calculation is based on 100% adoption rates, which is not maybe likely to happen any one time, but this is to illustrate what's the overall opportunity of reaching material reduction in the Frankfurt airport size. Whatever is then the realistic adoption rate scales down accordingly, but the reductions are considerable. This is the scale of the impact. Then about maintenance side, this ELLEGO CCR output voltage is always below 1 kilovolt. So it reduces the voltage. And it's also a continuous output signal, meaning that there is no voltage spikes. And that will lead to a situation where the circuit cable wearing will reduce. And it means that your existing cable lifetime will increase. So old cables can be used longer than otherwise. And of course, frequent halogen bulb replacement is not needed. There's a bit more information coming from that later. And reduction also means that this will reduce maintenance team time for other tasks. So it reduces the workload on the maintenance. And then of course, can also mean that this runway and taxiway maintenance breaks can be reduced. And overall, maintenance and economic efficiency will be increasing. And then also a practical example from real life, again, the Turku airport. The case was that usually they have more than 1,000 halogen bulbs being changed every 3 years. And of course, broken lamps in between that. And now what we installed these new LED lamps there, they have been now being used more than 2.5 years. And so far we don't have any broken LED lamps. So it's 2.5 years without bulb changes at all. So this of course means that the OPEX cost reduction has been occurring and maintenance working hours are avoided for that work. Again, this is from the real airport, real life example. Then about the economic efficiency, what happens? We already mentioned the energy savings, which was as such significant, but what happens is also the spare part consumption will drop down. And that will actually represent quite a lot of cost element here. In this graph, you see the relative changes between these three options. And to our understanding and estimates, the spare part consumption is the majority of the cost improvement, what's now available with this AGL 3.0. So it's not only the energy consumption. It's mainly about the spare part cost and maintenance work related to that. And that will, of course, save OPEX budgets and total cost of ownership. But this graph shows this kind of evaluation we have been using in the AGL 3.0, but we also need to note that now what we have this field experience from real airports. So as told, we don't have broken LED lamps so far. So it means that this real spare part consumption is something we have not yet seen. So this question marks kind of illustrates that this is something that might or will be better understood as the time goes by. But so far, no broken LED lamps. And what this would mean in airport scale, another example, scale to the Frankfurt am Main scale as an example. This is again with the 100% adoption rate. And information they have provided in their sustainability report earlier. Based on that calculation, we can evaluate that the OPEX spending used for the Airfield lighting could go from 2.5 million euros per year down to 0.8 with related CO2 emission reductions as well. And in case new equipment would be bought, the capex investment would be 18 million euros lower based on this estimated smaller and thinner transformers and cables and systems. Investment break-even time is estimated to be around 1.5 to 4 years. That of course depends quite a lot of the local conditions and what kind of circuits there are under study, how many lamps you have and what kind of existing infra you have there. But these evaluations has been reviewed and evaluated together with the actual airport personnel and considered realistic. So this is something achievable. Then the reuse part, the second principle of circular economy in AGL. How would that go? So the main principle here is that you maximize the reuse and minimize all the changes needed, meaning the changes in the equipment. That means that there are light fixture components and guidance sign components you already have, and you can keep on using them with the AGL 3.0. You can use existing circuit cables, you can use existing lamp transformers, and because the spare part consumption drops down, maybe you can also reuse inventory space to something else. And longer lifetime of the system components is also some sort of reuse, so you can keep on using the existing stuff longer. And you can also reuse the existing maintenance this capacity. So whatever is the team size, when the maintenance work effort for the AGL goes down, your team can do more other things. And this will again minimize the effort and cost also in the operation side and also on the new investment side. Then the third principle of circular economy, recycling. Let's see about that. In short, the AGL 3.0 makes recycling easier based on the following properties. So as we already heard, there will be less spare part waste, especially the a bit difficult kind of waste of electronics from the fixtures. And whatever you need to recycle, like your cables, that can be delayed because the lifetime gets longer. So it's some sort of recycling that as well. And then there was a question that if the diesel generator backup power can be replaced with renewable energy sources, that's of course one opportunity. And now with the existing situation, when Europe tries to or wants to reduce the oil consumption, this can be very, very important thing so that the airports can do their part on that. And of course, less material means less emissions from manufacturing phase, also from the operation phase and overall usage. So, but bottom line is that the use of green energy sources becomes easier with the AGL 3.0. And this improves environmental and social sustainability. And of course, when talking about the emissions, that's a very complex multi-factor topic. So let's remember that this carbon intensity of electricity production varies quite a lot based on what kind of electricity sources you are using and in what country you are located. So this is only to illustrate what kind of variance there is per country, and also on the right you can see the energy source types that what are the most difficult ones from the emission point of view. And of course, where the emission creation is high, there of course this AGL 3.0 benefits are maximal on the emission side. And if you remember that the 90% of electricity can be cut out, so it means quite a lot of for the carbon emission reduction, especially if you happen to use this non-renewable energy sources. So these were the circular economy principles ICA sees important, and now you have heard how this AGL 3.0 relates to those principles. And practically, we can conclude that it offers solutions for all of these three principles, as explained. And finally, we have been talking about the retrofit installations, new installations, but there are also development ongoing, so there will be a new designs for fixtures and maybe other components as well. And this is already happening. And these native LED fixtures can also be designed or modified so that they are compatible with the ELLEGO CCR. So it's not limited to these new products what we showed here, but other new products from other brands can also be designed. And this is a new technology, so we want to give these new benefits to airports, and we also want to welcome everybody to join to AGL 3.0 and make this all happen. Sustainability is waiting for us. In case you want to discuss more or ask something, there is my email address. You can always ask.
All right, I think that was the presentation part. Thank you, Terho. And now it's a perfect moment for you who are following still, ask questions if there is anything you want to ask. I've been very productive. I have already asked a couple of questions, and we have there also something from YouTube side. I will invite Otto to the studio. Just a second, and here we are. Hi, Otto.
Hello, everyone.
You were the presenter last time. Yeah, people already know you. So let's take the first one, because there you mentioned about the CO2 compensation fees, that this could have an impact to the reducing impact to the CO2 compensation fees. So how would you describe the potential impact of this AGL 3.0 technology for the CO2 emission goals and reduction? Because this is quite hot topic when the aviation sector is walking towards zero carbon emissions. So, or net zero carbon emissions. Zero is quite impossible.
Yes, so this is indeed an important topic, and as we know, many airports have target to carbon neutrality, and they are implementing reductions, and there's the certification system that then measures what they have achieved and what's left. And then there is also this compensation fee system used in order to reduce the overall emission. But maybe the most important part in the AGL3 can offer now for the carbon neutrality programs is that this is actually a real emission reduction which will happen with using this approach. And it will also materialize also in the equipment production phase when you calculate the total emission life cycles, and also during the operation. As you saw, the energy consumption goes down, and then of course depending on your energy sources and electricity sources, it depends on how big or small it will become. But AGL3 offers new ways to reduce emissions.
All right, thank you. Then I think I have one for Otto here. So technical question. In the ELLEGO series circuit, there is AC and no electronics in light fixture. Where does AC-DC conversion happens? And then that's the note, let's LEDs are driven by DC power always.
Yes, so correct. It's AC, of course, because of the transformers, it has to get through the inductive devices. The LED is a DC component. So the AC to DC conversation on transformation happens within the LED bulb. So the LED bulb is AC driven. So therefore, there's no need for anything active or any transformations between the CCR and the LED bulb. So it's all AC between the CCR and the LED bulb.
All right. Thank you, Otto. I produced another question which I thought could be interesting to the listeners. So this is about the costs. So what are the cost benefits for the end customer, in this case for the airport, if they want to invest on this technology and update their existing halogens to LEDs? What can you say about it?
Yes, as we saw in the presentation, there are multiple cost factors that will offer benefits for the airports. Maybe the first, most easy to understand is the electricity bill. The electricity consumption will go down, and of course, the cost of the energy goes down there on the operative side. Then there is this maintenance impact, meaning the maintenance amount of the work and also the consumption of spare parts. And then considering the full life cycle, also the waste part will be reduced. The cost of waste handling will go down. So those are the main three categories for the cost saving. But then, of course, it goes down to if you want to do the retrofit with the existing system or new installation. In case of the new installations, the investment budgets can be reduced because there are these material reduction and many parts or components can be reused. Not that much things to buy, like in typical investment.
All right. Yeah, that's true. One more thing, because you actually mentioned about this, installed base and where this product is already used, but because this is a new and quite recently released technology, there may be someone who is thinking, like how long these devices has been installed and in which location, like not necessarily the locations, but how many places and what has been the experience so far. Could you mention something about it as well?
Yes. So we understand, of course, that this AGL is a sort of reliability and safety related application and must be carefully designed and tested before wider use. And as mentioned, we are still in the early phases. We are now in the field testing phase at the moment, actually in 3 airports. They are using our products. And about how long they have been used. So the first LED lamps were installed 2.5 years ago. They have been in the operative use since then without any failures. And we have another test case where these LED lamps has been used almost 1 year at the moment, also without failures or any kind of problems. And we also have this third case where the CCR has been installed and it's been running now for 7 months, also without problems. And we of course want to increase the amount of these piloting cases. So in case any airport is willing to contact us, so please let's discuss further and see what kind of piloting circuit will be okay for you.
Thank you. Perfect. So if you don't have more questions, I want to thank you everyone for attending this seminar or the webinar. And as I mentioned at the beginning, if you were not here, this was the second part of our 2-part webinar series, but there will be more. And I want to say thank you, Terho, for sharing these sustainability insights, and also for Otto for the webinar 2 weeks ago. I also mentioned that these webinars are recorded, and both of them, the one from 2 weeks ago and this one, will be in ELLEGO website, LinkedIn, and YouTube. And yeah, I think I saw so many of you in Dubai last week, and it was absolutely amazing. And I think next industry event will be in Madrid in June, World ATM Congress. So perhaps we meet there. If you have any questions to Terho or Otto, you will find them from LinkedIn, and we also shared Terho's emails in the presentation. So if you didn't catch it, try first name dot last name at ellego.fi. And yeah, let me see. That's it. So no more questions. I think we have covered everything for today. So I wish you all a lovely day, and thank you for attending, and see you next time. Bye-bye.
Bye.
Bye.
Bye.